Yeah, so take page number 123. Page 123. Yeah, example 5. Example 5. Shreya and Jia has textbook.
Yes, ma'am.
Okay. So here they have given a figure. The figure somewhat looks like this. Okay. Correctly or not? Let's just see. Okay. Now what we have to mark A, B, C, and this is D and E. And they have marked some equalities on the figure itself. This and this are equal. And AC, side AC is equal to side BC. Angle this C and this angle are equal. So this is what is given. Have you all completed drawing?
Yes, ma'am.
Okay, so the question is, you have to prove the congruency or between the triangle DBC. Okay, so they have given you the triangle. The one triangle is this one. No, what's happening? DBC is this. BC is this triangle. So this is congruent to EAC. So let's do this triangle. EAC is this triangle. So we have to prove they are equal. So how can you do that? When you look in the figure, don't you think side AC and side BC, those are two sides of those triangles, right? AC is one triangle's one side, whereas BC is other triangles, similar side, right? They are equal. So one thing is clear. Second is, look at the angle A and angle B. Angle A belongs to triangle ACE, whereas angle B belongs to triangle BCD, right? So two things are there. Now you need one more thing. One more information is required to prove the congruency, right? Are you all with me? Hello?
Yes, ma'am.
Yes, ma'am.
Okay. What I told right now, are you, you're clear with, right? You all understood what I said?
Yes, ma'am.
Now, look at this part. Look at this part. Don't you think when I talk about the angle, angle C, when I say in triangle ACE, angle C has to be this one, right? When I say triangle ACE, angle C is what I have marked in a black color, right? Similarly, what is going to be...
That much, or it won't go the whole 180?
It won't go because see, I'm talking about triangle ACE. Because you know, in the triangle ACE, I have one side AC is equal to other triangles side BC. I have one information. Other information is angle A in triangle ACE is equal to angle B in triangle DCB. Okay, I need one more information. I need to equate one more information in both the triangles. That is what I'm looking for. Okay, so in that process, what I see is this triangles, this angle, okay, this angle and the other triangles. Other triangle is what? DCB, right? This angle. Okay, this is DCB's angle C. don't you think they have to be equal? Why equal? Is because in the question they have given, what is it that they have given? What they have given is angle ACD
ACD is equal to angle ECB.
ECB, right? This is the common part in both the triangle. Is it not? Both the triangles common part is just this part. So it has to be equal, right? Did you understand the logic? This part is what I need for this angle. This angle requires this part to complete the angle C. Angle ACE. If I have to say angle ACE, okay, what is angle ACE? Angle ACE is angle ACD plus angle DCE. Is it correct? Angle ACE is equal to angle ACD plus angle DCE. Do you agree or not? Look at this and tell me.
Yes, ma'am.
Vedat?
Yes, ma'am, I understood.
You understood. Now, similarly, when I say angle DCB, okay, angle DCB is the angle in triangle DCB. Okay, in DCB also, if you look at it, angle ECB plus angle DCE. Is it not same? Angle ACE is equal to angle ACD plus angle DCE. Similarly, angle DCB. Look at angle DCB. What is angle DCB? Angle ECB plus angle DCE. Yes or no?
Ma'am, can you repeat that?
Look at what I have written. Just look at the named angles. Angle DCB. Where is angle DCB coming? Can you see it? Can you I don't know whether you are able to clearly distinguish this.
Ma'am, I'm looking at the textbook.
Yeah, angle DCB. When I say angle DCB, that's the entire part. DCB is this entire thing, right? So in that entire part, how will I get that entire part? I am adding angle ECB with angle DCE.
Yes, ma'am.
So in that case, just look at this and see that take DCE as some figure. Even if you don't take it, it's okay. So just look at this. We know that angle ACD, angle ACD plus angle DCE is what? Okay, plus angle DCE. Can I equate it with angle ECB plus angle DCE?
Yes, ma'am.
Because angle DCE and both the sides angle DCE is there. That is same only. In the question they have given, these two guys are equal. Angle ACD and angle ECB are equal. That is clearly given in the question. Right? Vedat, Shreya and Jia, you are with me?
Yes, ma'am.
Yes, ma'am.
Yes. So this gives me what? Angle ACE. You can write angle ACE is equal to angle DCB. I'm just taking from this. Angle ACE is equal to angle DCB. Clear?
Yes, ma'am.
So this becomes my third angle. So what I'm going to do now is in triangle, I'm taking from the question, in triangle DBC and triangle EAC. In AC, we have to write that, what is angle ACE is equal to angle DCB. You will write proved above because we just did that. Then the other information is AC and BC are equal. AC is equal to BC, that is given to you. Now the third information is angle A and angle B. So you have to say the name properly. Angle EAC is equal to angle EAC is equal to angle DBC. Angle DBC. Angle DBC. Okay, that is also given to you. So 3 information is given to you. And if you look at it, the triangle DBC is congruent to triangle, which one? EAC. By what? By which rule?
ASA, angle side angle.
Angle side angle, ASA rule, by ASA rule. Okay. So I hope this is clear to 3 of you. And then when you look at this, they have asked for one more thing, that is DC and EC are equal. DC and EC are equal. DC and EC are equal. That you can take it from the congruency, right? Therefore, DC is equal to EC by CPCTC. Yes or no? Did you understand this clearly?
Yes, ma'am.
Yeah, that's all. So they have just given you this information. And if you want, you can write it from the textbook. Textbook, they have given an angle X and all that. Just that I have just used the name of the angle like E. What was the name? DCE is what I have used. Here they are using. No, they have given ACD and BCE as X. Even if you don't use it, it is fine. You can write it down. I want you guys to quickly write. 2 minutes.
Explain what is CPCTC. I didn't understand that.
Which one you did not understand, Gia?
The CPCTC.
What is CPCTC? Is that
Yeah,
your term?
yeah, ma'am.
Okay, corresponding parts of a congruent triangle is congruent. This is the full form of CPCTC. Now, if you look at the triangle, which all triangles are congruent? Triangle DBC and triangle EAC are congruent, right?
Yes.
These 2 triangles are congruent. So when you know these 2 triangles are congruent, you understand that DB is equal to EA, BC is equal to AC, then DC or CD is equal to EC. Then what all you understand? Angle D and angle E are equal, angle B and angle A are equal, and angle C and angle C, obviously, angle C are equal. So this 6 information you are getting from the order in which the congruency is written. Understood? So that is why we say CPCTC means corresponding parts of a congruent triangles are congruent. That's all. Congruent means they are equal.
Okay,
Make sense or?
Understood, ma'am.
Yeah, that's all. Okay, we thought you were saying something?
No, ma'am.
Okay. If you're done writing, we will move on to the next question.
I'm done.
Done. Okay. So let's try the 6th question then. Example 6. Okay. Example 6 is you have a parallelogram first, which is ABCD, ABCD. Okay. And then squares. Okay. 2 squares are attached to these parallelogram, this parallelogram, not these, this parallelogram. Okay, what is this? ABPQ. And we have one more square, That is, what is it? RD, okay, R or something, whatever. So we have to draw it like this because it has to come as a square. So somehow you managed to draw a proper square. I'm not getting a proper square. Okay, assume that this is a square, though it doesn't look good. RSDA. Now what they have given, some 90 degrees they have given. So draw all the 90 degrees like this. So that'll
Ma'am,
help.
so RDSA and ABQP are squares, right?
ABQP are squares, yes.
Yeah. So these two are squares. So all these angles are 90, right? In these two.
Yeah, all these angles are actually 90, yes. But they are not specifically saying R is 90, S is 90, Q is 90, P is 90. Maybe that is not required for our problem. That is why they are not mentioning. But if you ask me, all the squares, all the vertex of a square is actually 90 degree. Got it?
Yes, ma'am.
Yeah, and parallelogram means two sides, opposite sides are parallel, right? So this is a parallelogram, these two sides, that means they are parallel. Now B and A is also, okay, all this is all they have given. This is the information they have given. Now what is it that you have to prove? First, draw the figure correctly. Then we will think of what needs to be proven. Okay. In this, you have to prove angle SAQ is equal to angle ABC. That's the first thing. Then SQ is equal to AC. So two things you are asked to prove. Angle SAQ, what is SAQ? This is angle SAQ. What is angle ABC? This is angle ABC. So these two are equal is what you have to prove. Okay. If you're done, we will start discussing.
Done, ma'am.
Done, ma'am.
Yeah. So here, what they are starting with is, we are considering angle ABC. I'm just following the textbook's approach, okay? Angle ABC is considered as X because we don't know what is ABC. So just take it as X. That's it, okay? If ABC is X, what is going to be, okay, by the way, in a parallelogram, you know that when you add two adjacent side, the angles of sum of two adjacent side, what is it? Sum of angles of adjacent sides of a parallelogram are what? See, if I angle X and this angle, what is its value? Like if I do angle DAB plus DAB plus angle ABC, what is the value of it in a parallelogram?
180.
180. Why? Because they are parallel. Okay, that is the reason. See, you have learned it in a parallel. You have learned transversal. You remember this transversal concept you have learned in probably 7th or 8th?
Yes, ma'am.
Parallel lines, a transversal cuts the or passes through the two parallel lines, right? So what is the sum of interior angles? Co-interior angles, what is the sum? It's always 180 degree, is it not? You're understanding? Huh? So that is
Ma'am,
the
so you're saying that angle A in this one is equal to angle B in this parallelogram?
no. That's not what I'm saying. Angle A plus angle B is 180 degree. That's what I'm saying.
Ma'am, so you're saying in this one, is it like
Oh, did I say
angle?
equal? I'm sorry. If I said it is equal, I'm sorry. Then that's not what I meant. This and this, when you sum it up, I should get 180. That is called supplementary. Understood? or I confused you? Vidat, is it clear?
Yes, ma'am.
Oh, Jia and Shreya? So just that in a parallelogram, when you sum up adjacent angles, they have to be supplementary. Supplementary means 180 degree. Okay. So now let me do angle DAB plus angle ABC is 180 degree. So what is going to be angle DAB? DAB is 180 minus X. Correct or not? Did you understand this? Because I said angle ABC is X. So if angle ABC is X, DAB is going to be 180 minus X, right?
Yes, ma'am.
This is 180 minus X. And okay, now consider what in the textbook, what they are saying is, consider all the angles around A. Do you see 4 angles around A? 4 angles are there, right? What are they? Angle SAQ plus angle QAB plus angle
DAB
plus angle
SAD is equal to 360.
Correct. SAD equal to 360 degrees. So I am adding up all the 4 angles around the vertex A. So this is one angle, 1, plus this, plus this, plus this. So this gives me a complete angle. Complete angle is nothing but 360 degree, right? Now here I substitute the values. Angle SAQ, I don't know the value, write as it is, plus QAB is what? QAB, they have given us 90 degree, right? Do you see in the corner, we have marked 90 degree. Yes or no? So QAB gives me 90 degree. What is DAB? DAB is 180 minus X plus what is SAD? Again 90 degree. That is equal to 360. Is it not? Yes or no? So now
Yes, ma'am.
90 plus 90 is 180, 180 plus 180 is 360. So angle SAQ plus 360 minus X equal to 360. So I can take these two guys to this side. So what do I get? Angle SAQ is equal to 360 minus 360 plus X. So angle SAQ is equal to X. What is X? X is equal to angle ABC. We started with that, right? Angle ABC is equal to X. So did we prove that or not?
Yes, ma'am.
That's all. So we write hence proved. Okay. You write this down and then we will do the second part.
No, I can't hear you.
I did not say anything. Did you
Oh,
complete
okay,
writing?
Yes, ma'am.
Okay. Now we will write SQ and AC. 1 minute, SQ and AC. Okay. Okay. Now, if you have completed, all of you have completed writing, let us do the second part of the problem. What second part says is SQ is equal to AC. Okay. So when they say SQ is equal to AC, you have to basically think of triangles where SQ is one triangle's one side and AC is other triangles one side. Okay, so you establish congruency between those two triangles and then you just say by CP/CTC these two are equal. That's it. Okay, that's the idea. So here in this triangle, when you look at it.
So what you said is just take two triangles where they are congruent and these two angles, I mean, sides are there. And then we Yeah.
Consider two triangles, two possible triangles where SQ is one triangle's one side and AC is another triangle's another side. Like that.
Got it.
Okay. So now let me just, when you look at it, this is SQ and AQ. SQ, AQ. What is the side they were talking about? SQ. So SQ, anyway, we don't have connection. You have to connect them. You are going to connect these two guys and making it as triangle SAQ or SQA, whatever. That you have to see what all are matching, that you have to see and create a match. Okay. The order we will decide at the end, but at the moment you identify the triangle. Now, second triangle AC is the side. So definitely you have to mark it like this. AC is going to be this one. So AC, I'm thinking of taking ABC as the triangle. Sometimes ABC might not work. You might have to take the other half. Okay, but it is a parallelogram. Both the halves are same only. Logic will be same. So ABC or DAC, since it's a parallelogram equally, the diagonal equally divides, right? So parallelogram, in a parallelogram, diagonal equally divides the parallelogram into two equal triangles. So you can choose ABC or ADC. That doesn't matter. Is it clear? Yes or no? Yeah. Okay. So now the next thing what I want to show you is, we know that what we know, ADRS is a square, right? When ADRS is a square, okay, ADRS is a square, ADRS, this side and this side are going to be equal, is it not?
Yes,
I have to pick up a different color then, not black, which color? Red color. Okay, this side and this side are going to be equal. Don't you think in a parallelogram this side is also equal? DA and BC will be equal. Yes or no? Don't you think so?
Yes, ma'am.
They will be equal, right? DA and AD and BC will be equal. So that way you have to consider SA, and similarly it's a square. So when I say it's a square, this side has to be equal also, right? SR, SA, AD, RS, RD, all the sides will be equal in a square. Correct or not? Confused you? Huh? So all the sides will be equal. So SA, when I say SA and AD are going to be equal. Similarly, RS and those things are going to be equal. Fine. Now, what about, okay, AD and BC are also going to be equal, right? Did you understand? So what all are the equalities I mentioned? SA and AD are equal. Similarly, AD and BC are equal. Why AD and BC are equal? Because it is a parallelogram, right? Opposite sides of a parallelogram. This is opposite sides of a parallelogram. Whereas SA and AD are equal because it is sides of a square. Is it clear or not? Why I have considered SA equal to AD and why I have considered AD is equal to BC.
Yes, ma'am.
Yeah, clear. Okay, now let's, when we combine, can we say SA and BC are equal? We can combine all this equation, right? SA equal to AD and AD is equal to BC. So can you say SA is equal to BC? Can I say, another beautiful color I'll take, purple color. I'm saying SA is equal to BC. Do you agree or not? I'm saying SA is equal to BC. Why? Shreya, you understood this? Vidhat, you're also getting it, right?
Yes, ma'am.
So SA, when I combine these two ideas, I understand that SA is equal to, these two guys are equal. That's it. SA is equal to BC. Now, what about AQ? AQ, similar concept, or I can say AQ and this, won't that be equal? AQ and AB are equal or not? Because that's again a square. Remember, ABPQ is a square. Okay. When I say ABPQ is a square, all the sides of a square needs to be equal. Got it? Yes or no?
Yes, ma'am.
So side AQ and side AB are going to be equal. Understand? AQ, side AQ is the side of triangle SAQ, the lower triangle, okay, lower triangle, whereas AB is a side of upper triangle. Upper triangle is ABC. So we are able to prove two sides equal. Similarly, we have also proved, just before starting, we have proved that angle, what did we prove? Angle SAQ. This angle, SAQ angle, is equal to ABC. We have proved. So three things did we prove or not? Did you all understand what I'm saying? Three things we were able to show the equality, right?
Yes, ma'am.
So SAS, side, angle, side. Which are the sides? One side, angle, side. Based on side, angle, side, these two triangles are congruent. Can I prove or not? Gia and Shreya, did you get this?
Yes, ma'am.
That's all. So based on congruency, SQ is equal to AC. That's it. Based on, because these two triangles are congruent, you can write SQ is equal to AC and you're done. Now, can you write down this part from the textbook? Textbook has almost covered whatever I told. So can you just look at it and then write it down? What is there in the textbook? Just write it down in your notebook.
Okay, ma'am.
When you write, no, just try to, understand what you're writing. If you are confused, you can ask me again. No problem.
Done, ma'am.
You're done? Okay. Can you draw the next figure also? I mean, in example 7.
Yes, ma'am.
Yeah. Okay, let's do it. Example 7. I hope you have completed drawing. We have two parallelograms here. Let me first draw it. Okay, this is one parallelogram. The other parallelogram has to go like like this probably. And like this. Okay, it's like this. Okay, so I have got two parallelograms here. One is AB CD, and the other one is ABFE. Now what they have told us, DC is equal to CF is equal to FE. All of them are equal. Fine. O is the midpoint of BC. O is the midpoint of BC means this and this side are going to be equal. Oh wait, I cannot use it. It's the same representation. These two are equal. Okay, now what? Nothing else. So they are parallelograms. That's the most important information. You know that when they are parallelogram, you have to think that, BC can see the line AF and BE are parallel, right? AF and BE are going to be parallel. So BC can be acting as a transversal. Correct or not? Hello?
Yes, ma'am.
Got it, no? So you can use alternate angle concept and all that here. Similarly, when you look at ABCD, parallelogram ABCD, side AB and side CD are parallel to each other. When they are parallel, AF is acting as a transversal. So just think, these are the options available for you so that you can figure out the angles, equality and all that. So I just told you, that's it. Now, again, here also I'm following what is mentioned in the textbook. The approach is mentioned in the textbook. First, we are picking up the two small triangles, which are, wait, I have given you wrong information. They have not given DC equal to CF equal to FE. You are asked to prove, okay, prove DC is equal to CF is equal to FE. They have not given you that information, okay? You have to prove. Okay, so now, first, what I'm going to do is we will just figure out about the CF part. We are just trying to figure out CF part. So what is it? Just pick up the triangle. Which all triangles? ABO, these two triangles, this ABO part, ABO triangle, and it's that other small triangle. ABO is one triangle, other triangle is CFO. Okay, so these two triangles is what I'm going to consider. So what all information you know from these two triangles, triangle ABO and triangle CFO. We know that OB is equal to OC. Why? Because it's given that O is the midpoint of BC is given, right? So write OB is equal to OC. Next information, what you know is, if this angle is something, what would be this angle? Don't you think both the angles will be same? Angle AOB will be equal to angle AOB will be COF. Why? Vertically opposite angle. Have you heard of this vertically opposite angles?
Yes, ma'am.
So angle AOB and COF, both of them are going to be vertically opposite angles. What is next? Now we have to think of our parallel lines transversal concept. Okay, so if I consider, 1 minute, which all angles I should consider as, if AB and, okay, if I consider AB and AB is parallel to CD. Okay. Just we know that AB is parallel to CD considering the parallelogram ABCD. BC will act as a, BC is a transversal. Is it correct? AB and, no, sorry. Yeah, it is correct. AB and CD are parallel lines. BC is a transversal. Okay, in that case, don't you think if it is a transversal, this angle will be equal to this angle? Yes or no? Shreya, Vidat, all of you are with me?
Yes, ma'am.
Yes, ma'am.
So it's a transversal, right? BC is a transversal. So when BC is acting as a transversal, this is our alternate angles, interior alternate angles, right? So angle B, angle ABO and angle OCF, won't that be equal? That's my question. That's alternate angle, right? So you just need to write, okay, all this you can write as a reason, but I just wrote it so that you understand it. So you can write angle OBA is equal to angle OCF. The reason what they have mentioned is, yeah, alternate angles as AB is parallel to CD. Okay, they have written everything, and BC is a transversal. In the textbook, everything is written. Okay. So the three things we have proved: OB equal to OC, angle AOB equal to angle COF, angle OBA equal to angle OCF. So when we have three information, what all we have? Angle, side, angle, right? And based on ASA, we are able to prove the congruency. So just write triangle ABO is congruent to triangle FCO. How? By ASA. Okay. So this gives you the one information, that is AB and CF are equal. AB is equal to CF. You are just writing how? By CPCTC. Just write it till this point. We are still not done, but still you can please write it. If you write it down, then it is, the remaining part is very simple. See, AB and we just proved that AB and CF are equal, right? If AB and CF are equal, what is the parallel side of AB? In the triangle ABCD, AB, if I say AB is equal, what will be AB equal to? Don't you think AB is equal to CD? Did you understand? Look at the parallelogram ABCD. Can I say in the parallelogram ABCD, side AB is equal to side CD? Can I say that?
Yes, ma'am.
So that is one information, side AB equal to CD. Okay. Similarly, look at the other parallelogram, which is ABEF. ABEF, can I say side AB is equal to side EF? Can I say that AB, side AB is equal to side EF? This side and this side are equal, can I say? In that parallelogram, ABEF parallelogram, they are opposite sides. AB and EF are opposite sides. So I can say AB is equal to EF. So if I combine all the three equations, what do I get? CF is equal to CD is equal to EF. That's what they have asked you to prove. So we just say hence proved. That's it. I hope this is clear. You can just copy it from the textbook itself. You don't need to, whatever I wrote is just for you guys to understand it. So please, textbook is more of, proof style. So just copy from that. Shreya and Gia, did you understand this?
Yes, ma'am.
Okay, just copy it. Done?
Yes, ma'am.
Yeah. Okay, so next question shall we do? And then we will wind up. 8th question. That's the last problem in this chapter. So example 8. Oh, by the way, Shreya and Jia, are you coming tomorrow to write the test?
Yes, ma'am.
Okay.
It's at 3 o'clock, right, ma'am?
Okay, 3 o'clock, right? What time you can come 3 o'clock? Because I have a class at 4. I completely forgot about that. So I have kept a class.
Come at like 2:30 or 3. 2:30.
45, it's a 45 minutes test problem,
Okay,
right?
ma'am, we'll come at 3 itself.
Yeah, make it at 3 itself so you can finish it by 3:45.
Okay, ma'am.
Okay. So example 8 is here. You have to draw a square first. And then, okay, square is ABCD. And then ABCD. Okay. Now, what is PC? What is PC? Anything? I don't know. PQ is perpendicular. Okay. PQ is, before that, they are talking about M. M is the midpoint of AB. Fine. So we have M. So this side and this side are going to be equal. Fine. Now PQ is perpendicular to CM. What is CM? CM is just a line. They are connecting C and M. That's it. C and M they are connecting. Fine. Now PQ is a line perpendicular to, they're just drawing a perpendicular. Perpendicular means that's going to be 90 degree. That's all. So which is, this is going to be 90 degree. Okay. So this is 90 degree. This also will be usually 90 degree. But even if you don't draw, that's fine. Now what P is this and the other side was Q. Fine. So PQ is perpendicular to CM. Okay. CB produces to meet PQ at point Q. Okay. So CB is producing means you are just extending it so that meets. Okay, fine. Now what are you asked to prove? PA and BQ are equal. So prove PA is equal to BQ. See, when they ask you PA is equal to BQ, which triangle you need to consider immediately? Think and tell me. Which triangle you are going to consider? They are saying PA is equal to BQ. So which triangles have PA and BQ coming as sides? Are you able to hear me? Hello? With that,
Yes,
are you there? Yes. So
yeah.
I told you, the question is prove PA and BQ are equal. So we have to consider two triangles in which PA is one triangle to one side, BQ is another triangle's other side. I mean, some side. Okay, so
AM and BM are equal.
Right.
Angle PMA and angle QMB are equal because they're vertically opposite.
Correct.
And angle PM and QM are equal because
Angle PM means what? Side PM. Is that what you meant? No.
Side PM, I meant.
But
Are
why
they
side
equal?
PM and side? Why are they equal?
The perpendicular here.
Did
Okay,
they
no,
say
never
no?
mind.
They did not say bisector. No,
Yeah,
no.
never mind.
That's okay. But you know what I was saying is which all triangles you need to consider. At least identify that first. You are trying to you're coming very close, but the triangle name you did not say. Triangle name is just say PAM.
PAM and triangle QBM.
QB, because we are not, we still have not identified the congruency order. Okay, we are just considering two triangle, and after proving only we will say in which order they are congruent. So when you say the congruency, at that time you have to be careful about the order in which you write the vertices. At the moment you can write in any order because you are not establishing the congruency. Now you are going to establish by proving it. How are you proving? By writing AM is equal to BM and all that stuff. Okay. Now, tell me it's a square, right? When it is a square, don't you think this angle and this angle are going to be 180 degree? Sorry, 90 degree in a square.
Yes, ma'am. Sides of square.
So we get it, right? So angle MBQ also is going to be what? 90 degree, is it not? Got it, right? So you can write angle PAM is equal to angle MBQ is equal to 90 degree because
and angle PMA and angle QMB are equal because of vertically opposite.
Exactly. So angles in a square. So that's it. This information is given to you. And angle, as you said, angle PMA is equal to angle BMQ. Why? Vertically opposite angles. So now you can establish the congruency. So three things you have proved. Now you can say which all triangles are equal, that you can say. Triangle, I think triangle PAM is congruent to triangle corresponding to P, which side come? Q comes. Q corresponding to A comes B, and the corresponding to M comes M only, right? Yeah. Understood? Is it clear or not? Shreya and Gia? No response. Yeah,
Yes, ma'am.
that's all. So we were able to prove that these two triangles, these two small triangles. So based on that, PA is equal to BQ by CPCTC. PA and QB or BQ. They are by CPCTC, they are equal. Okay. Now let's do the second part. What is the second part saying? What is CP? CP, what is CP? Oh, okay. CP is like this, you have to connect. That I did not connect. Okay. CP is what? Next part is CP is equal to AB plus PA. How will you prove that? CP is AB plus PA. That's correct. So in this triangle itself, we have proved few things. PA is BQ, we have proved. One more thing we will prove. But before we prove, okay, we have to prove on a next level of congruency. Okay, by the way, I forgot to tell you one thing. How is PAM and QBM are congruent based on which rule? This one, based on which rule they are congruent? Angle side angle, right? Hello, are you there? Yes, angle side angle. Based on that rule, I forgot to mention that. Okay. Now, the next level is CP is what you are checking. CP's thing is what you're going to check. So for that, you have to consider the next two triangles. And the next two triangle is going to be, one is CPM and the other is going to be CQM. Okay, I'm not necessarily saying in the right order because we still have not established the congruency. So I can say consider triangle CPM and CQM. I can say it in any order. Okay. So what will you write? Consider triangle. I mean, you can copy from the textbook. Okay, it's not there. In textbook, they have not mentioned like that, but you can write consider triangle CPM and triangle CQM. Okay, in that you are trying to establish the similarities. So we can say that PM is equal to MQ. Can you say that? PM is equal to MQ. Can you say? PM is equal to MQ. Why? Okay, here you write PM is equal to MQ by CPCTC of the previous thing. PM and MQ are coming part of that triangle, no, that small triangle. PM is one side of one triangle or your hypotenuse of PAM. And similarly, MQ is hypotenuse of triangle BQM. So they are equal, correct or not? Hello. Are you guys with me?
Yes, ma'am.
Yes, okay. So here, look at this. What I'm saying is this and this side are equal based on the previous congruency. Previous two triangles congruency, they were CPCTC, they were corresponding sides. Now the next is this angle. This angle and this angle are equal. Angle PMC and angle QMC are equal. Right or wrong? So two things I have established. Third thing is CM. CM is common to CM. Both the triangles have CM as a common side. So did I find three things now? So can I establish the congruency between the bigger two triangles? Are you getting me?
Yes, ma'am.
Yes. So please.
Yes, ma'am.
Yes. So three things are already established, right? So one is PM equal to MQ. Second is the angle PMC, which is 90 degree. Similarly, CMQ is 90 degree. Now CM is a common side for both the triangles. So because of that, these two triangles are also congruent. Okay. When these two triangles are congruent, you can say that CP is equal to CQ, right? They are the corresponding sides. CP is equal to CQ. By the way, the congruency was based on SAS. Okay, by SAS we have proved that congruency. Now we say side CP and side CQ are equal. What is CQ? CQ is nothing but CB plus BQ. That's it. We have proved. And what is BQ? That also we can change. What is BQ? CB plus PA, because by previous congruency we proved that PA and BQ are equal. When PA and BQ are equal, in the place of BQ, you just write PA, hence proved. Clear?
Yes, ma'am.
Yeah. Can you please write this down and then wind up? Please finish writing and then only wind
I
up.
already read.
You did? Okay. A copy from the textbook. Okay. I'm just telling you so that
Okay,
you
ma'am.
understand it. That's all. But you know, technically when you write, it has to be following the way in the textbook.
Okay, ma'am.
Okay.
Okay, thank you,
Okay.
ma'am.
So yeah, bye. Shreya and both of you are done?
Yes, ma'am. Yes, ma'am.
Yeah. Okay then. So see you tomorrow then. Bye.
Bye, ma'am. Thank you, ma'am. Bye.
Bye.